This lesson is pre-algebra, section 6.3, similar figures and scale drawings. The objective of this lesson is to solve problems that involve similar figures and scale drawings. So first, to define similar figures. The similar figures have the same shape but not necessarily the same size. So in this little note box here, it's telling you they have two different properties, right? The corresponding angles have equal measures, and then the lengths of corresponding sides are in proportion. So what does that mean? If we look to this box here, we have two triangles. These two triangles are going to be similar triangles. When we say corresponding angles have equal measure, right? These two angles have the same measure. These two angles have the same measure, and these two angles have the same measure. So they're corresponding angles. It's basically taking the same shape and just making it bigger or smaller, shrinking it. That's what it means to have similar figures. And then the lengths of corresponding sides are in proportion. So this side corresponds with this side, right? So it's about 50% higher, larger. And then this one is 50% higher, and then this is 50% larger. So the sides are going to be in proportion, and the angles are going to be the same for similar figures. Okay, so let's see this in action. We're going to start with a parallelogram. This is saying parallelogram A, B, C, D. This is how we name parallelograms. That means A, B, C, D. And the naming convention always goes around. Like A should be next to B, B should be next to C, C should be next to D. Okay, and it's saying this little squiggle means it's similar. So it's saying this parallelogram here, A, B, C, D, is similar to parallelogram E, F, G, H. It's also written in this order, meaning that A corresponds to E, right? That this is very on purpose that this A and this E are written first. That means these two angles are going to be corresponding, and since they're similar, they're going to have the same angle. B and F have the same, these are corresponding, also means the sides are corresponding. AB is corresponding to EF. So it's very specific when it says this. It's not just randomly written, right? Because you could call this parallelogram GHEF, but we're not putting it in that order because ABCD is in this order, so they're corresponding. Okay, so using the fact that these two parallelograms are similar, we know which ones correspond based on the way that it's written. We're going to find the value of x here. So it's going to be the length of this side AD. Well, we know that this AD corresponds to EH, and then AB corresponds to EF, and lengths are in proportion with each other. So what we're going to do is set up a proportion so we can solve for x, just like we did in the last section. Okay, so we're going to say x over 18, because these two are corresponding. This is from this first parallelogram. This is from the second. Is going to equal, now since we have the corresponding side from this parallelogram on top here, we're going to put this one on top here. So that's we're going to put 16 and then over 24. So be careful about how you set these up. You can't do x over 18 equals 24 over 16. It's not going to work. So the corresponding sides have to be set up correctly. Okay, let's solve for x. Let's use our cross multiplying here. And let's say 24 times x equals 18 times 16. So let's find out what 18 times 16 is. That is 288. All right, let's set up our railroad tracks, and then we're going to divide both sides by 24. And we're going to get x equals 12. Okay, so the question, that is the answer. It says find the value of x, so x equals 12. Okay, so now you have one to try on your own. This is saying there's not a picture, so I would draw one. Parallelogram KLMN is similar to parallelogram ABCD, so we're using this parallelogram here. Okay, so draw your KLMN, and remember, when you draw it, you're going to go, right, since it's similar to ABCD, you're draw it just like you draw this one, right? ABCD KLMN, but saying KL, so, and label it that way, right? KLMN. KL is 21, find KN. Okay, so try that on your own, and then check back for the answer. Okay, so KN, oh, this says actually round to the nearest tenth. So this should be x equals about 16, right? Because, oh, sorry, no, not 10th, right? 10th place is going to be this place here. So 15.7, but this is a 5, so we're going to make that an 8. So we're going to round this to be about 15.8. Okay, so hopefully you got 15.8. There we go. Okay, check your work. Let me know if you have questions. Okay, we're moving on to something called indirect measurement. This is a way to measure distances that are difficult to measure by using similar figures. We can measure, you can't measure that directly. So in this example, we have, we're trying to figure out the height of a tree. And we can't really, we can't climb to the top of the tree and use a tape measure to measure it, right? But what we can do is use similar figures. So if you're looking at this tree and you are 5 feet tall, or whoever, this guy is 5 feet tall, and then this tree, we're trying to figure out this length here. So let's put an X here. We want to know, actually, let me read the problem. A tree casts a shadow 10 feet long. A 5-foot woman, sorry, it was not a man, casts a shadow 4 feet long. The triangle shown for the woman and her shadow is similar to the triangle shown for the tree and its shadow. How tall is the tree? Okay, so we're trying to figure out this length here. We're going to call that X. The shadow, since the sun is coming from the same angle, right, this angle here is going to be congruent to this angle here. And then this angle here is going to be congruent to here, and this is a 90-degree angle. So these are similar triangles. And that means we can use proportions. So we know that she is 5 feet tall. We know that her shadow is 4 feet tall. We don't know how tall the tree is, but we do know its shadow is 10 feet tall. So what we can do is say 5 over x, right, the height of the woman over the height of the tree equals the height of the woman's shadow over the tree's shadow. Make sure you're putting these in proportion correctly. You could also do 5 over 4 x over 10. You could do woman's height, you could do her height, shadow height, tree's height, tree's shadow, shadow's height. But we're going to do woman's height, tree's height, woman's shadow, tree's shadow. Okay, so let's solve for x using our cross multiplying. 5 times 10 is 50. 4 times x is 4x. Like railroad tracks, we want to get x by itself, so we're going to divide by 4 to get x by itself. That means we have to divide by 4 on the other side of the railroad tracks. So here we're left with x, because my 4 divided by 4 is just 1. And 50 divided by 4 is going to be a decimal, right? It is going to be 12.5. Okay, and let's see, how tall is the tree? So the tree is 12.5 feet tall. All right, so that's how you use indirect measurement. You use similar figures to compute distances that are difficult to measure directly. Okay, so here is a problem for you to try on your own. A building is 70 feet high. A building 70 feet high casts a 150-foot shadow. A nearby flagpole casts a 60-foot shadow. Draw a diagram and then use similar triangles to find the height of the flagpole. Okay, so draw the diagram similar to this one, right? But you have a building and a flagpole and 2 shadows. You're going to be making similar triangles. Okay, so try this on your own and then check back for the answer. Push pause. Okay, hopefully you drew your picture, solved your proportions, and got that the height of the flagpole is 28 feet. So push pause and check your work. And let me know if you have questions. Okay, we're going to look at one more type of application with proportions, and that is with scale drawings. So a scale drawing is an enlarged or reduced drawing that is similar to an actual object or place. So in example 3, we're going to use the example of a map. Right? If you have a map of a place, right, it's going to be a reduced drawing, but it's going to be to scale. So in this map, we have a distance between Santa Rosa and Sacramento on a map. The scale of the map is 1 inch equals 44 miles. So the ratio or the scale is 1 to 44. So using that scale, how far from Sacramento is Santa Rosa? So what we're going to do is in the scale drawing, we can see here's Sacramento, here's Santa Rosa. This is using this ruler 1.5 inches. Okay, so if we know that we have 1 inch is 44 miles, that's the scale, that proportion is going to be the same as, and the inches are going to go on top, 1.5 inches, and then we don't know in real life how many miles that is, so we're going to find that out. We're going to call that x. So we're going to cross multiply these, and we can ignore the units at this point. I just wrote them so that you can see which one, right? The inch goes on top, miles goes on bottom, but they're not, they actually cancel. So 1 times x is x, 44 times 1.5 is 66. And we don't actually have to solve for that, right? X equals 66, and units, right, are miles. So Sacramento is 66 miles from Santa Rosa. Okay, so we have one for you to try on your own. Check back for the answer, and then we'll be done. So the distance between Sacramento to San Jose now is about 121 miles using the same scale as above. What is the approximate map distance between these two cities? So try this on your own and check back for the solution. Okay, so hopefully you got 2.75 inches when you set up your proportions. And that is it.